here is the problem about undamped free vibration problem. Okay, look at this problem. In this problem, they said if there is no damping, which means it's undamped, right? And also, when you read the problem, there's no information about like external force, like after like the vibration was started, right? So that's why we can say this is the undamped free vibration mode. Okay, and also like we already know the mathematical model of this one, right? Like we already talked about this one, right? So it is n u double prime plus k u is equal to 0. Okay, so now let's try to find all the given information in here, right? So here we go. The first line, they said mass is given, which is 100 gram, right? So we can say 100 gram is your initial mass, not initial mass, like just mass of your object, right? And then it is stretching a spring 5 centimeter, which means this is not a dynamics, but like it is kind of like equilibrium position, right? When you hang the object like in this on this spring, then it is just stretching 5 centimeter. Okay, in the previous slide, I used L sign for this one, right? And then what else? Oh, there we go. Undamped, and it starts from equilibrium position, which means U0 is 0, right? Equilibrium position, right? And then with the downward velocity 10 centimeter per second, that is initial velocity. But keep that in mind, we say like going down as the positive, right? So we can say it is positive 10 centimeter per second, okay? So like with all this given information, let me update my differential equation, okay? So let me plug in M in there. It is 100 gram U double prime plus K U equal to 0. Is that okay? Oh, wait a minute. Like we cannot complete this differential because we do not have like spring constant K yet, right? How can you find it? We're going to use the equilibrium position, right? What does that mean? The spring force and the like gravitational force, which is weight, must be equal to each other, right? So from the equilibrium solution, no, equilibrium position, that's what I'm saying. Which means mg must be equal to KL, right? So what is that? Let me use all the units, okay? So to make sure you have like, correct units, okay? It is 100 gram, which is mass, and gravity is 9.8 meter per second square. But for this problem, they are using centimeter, right? And so like we are not going to use 9.8 meter per second square, but we're going to use 980 centimeter per second square, okay? 980. So we have to use the same unit for everywhere, okay? And equal to K, which is spring constant that we have to find. And the stretching by that weight is, what is that, 5 centimeter, right? That's it, okay? So we're gonna multiply your left-hand side and divide by 5 centimeter at the same time. Then this will be 98,000 over 5 centimeter we cancel out, and gram per second squared is your spring constant, okay? When you simplify, your K is, what is it? 19600 gram per second squared, okay? And now let me update my differential equation, okay? Here we go. And my differential equation is 100 U double prime plus 19,600 U equals 0. There we go. It is homogeneous second order linear differential equation with constant coefficient, right? Which means we can solve it, okay? So let me divide by 100 like first, then we can have like much simpler one. U double prime plus 196 U equal to 0. Then definitely we're going to use the characteristic equation, right? So then the characteristic equation is R squared plus 196 equal to 0, okay? And minus 196 on both sides and take the square root of both sides, okay? Then your R is plus and minus 14R, right? There we go, it's complex number. Then we know how we can find general solution of this one, right? And but for this case, there's no real number part, but we have only complex number part, right? So here we go. The general solution, ut is equal to coefficient 8 times e to the 0, which is 1. So you don't have to worry about exponential function part. And we're going to write cosine 14t. and b sine 14t. That's it. This is your general solution. Okay. Now it is time to use the initial condition, right? What was first one? The initial position was equilibrium, which means there's no displacement, right? So plug in 0. A times cosine 0 plus b times sine 0. Since sine is equal to 0, we can easily find A is equal to 0. Okay, then update. My solution curve is equal to b times sine 14t. Okay, and to use the second initial condition, we have to take the derivative, right? Then u prime t is equal to 14b cosine 14t. I'm talking about chain, right? And then second one. Since u prime of 0 equal 10, then plug in 0. So your b is 10 over 4, which is 5 over 2. Okay, that's it. Now we found the solution of this problem. Okay, here we go. Then my ut is equal to 5 over 2 sine 14t. This is my solution, right? Give me 1 second. Did I make a mistake or not? Oh. And then we plug in 0 in there, and it is 10 equal to 14b times cosine 0. Okay, since cosine 0 equal to 1, and we can easily find b as 10 over 14, which is 5 over 7. Okay, now let's update your final solution. Okay, your solution is displacement ut is equal to what is it? 5 over 7 sine of 14t. That's it. Well, and we would like to talk about the frequency, period, amplitude, and phase of this one. But in the previous problem, we learned how we can combine cosine plus sine function form, right? But for this case, we don't have to do anything. Okay, since it's single trig function, we can easily find all those things. Okay, the first of all, let's start from the amplitude, right? Amplitude is the coefficient of your sine function, right? There we go. Amplitude is 5 or 7, right? Definitely like your solution curve has the minimum negative 5 over 7 and maximum 5 over 7, okay? That's it, okay? Then what is frequency then? Definitely frequency is the coefficient of t, right? We note it by omega, that is equal to 14, right? Then how can you find period? That is definitely 2 pi over omega, right? So this case is 2 pi over 14, which is pi over 7. Okay? And at this moment, okay, let me finish to find like all those things, and then we can talk about the other, okay? And what is the phase? Well, to find the phase, like it might be better to start from here, okay? The phase is delta for this case, right? Then what is delta, by the way? Since the delta is not delta, but like tangent delta, that's what I gave you in the previous problem, right? Tangent delta is equal to b over a, okay? And your b was 5 over 7, but my a is equal to 0, which is undefined, or we can say it's plus infinity, right? But think about it. And as I told you, your b was r sine delta, and your a is r cosine delta, right? And like this is the case, your r cosine delta equal to 0, right? And r cosine delta equals 0, which means your delta should be equal to pi over 2. Does it make sense? So we can find like delta with this way, okay? So I can say the phase delta is pi over 2, okay? So like with all this information, let me give you the solution curve, okay? You can try to use the like, the graphing calculator or like any like website, but like, you can easily find this one. Okay, here we go. It is definitely the sine curve, right? And but keep that in mind, like this delta, like, constant with the like cosine, right? That's why like there's space, right? So like basically like your solution, like a solution curve form must be cosine. That's why we have like that phase, okay? And let me show you the like figure of like this solution, okay? Here we go. This is t, and y-axis is displacement u, okay? And as you found, like the amplitude was 5/7, which means your like, oscillating, I mean, sine curve must be like between -5/7 to 5/7, right? And then since its sine function is start from 0, and definitely is oscillating like this, right? And this point is the phase, right? So, but for this case, like it must be like, like delta over omega, which is pi over 28. And the period was pi over 7, which means the second peak point will be delta over 2 omega plus pi over 7. We are talking about period, okay? Is that okay? And that's it, right? So also like, we talked about this one, amplitude, right? Am I doing right? So in the problem, oh, I ask you to find the first return. When does the mass first return to its equilibrium position, right? Here we go. Find the time, I mean, okay? Okay, which means u equals 0 case, okay? After like the motion was started, okay? Which means we're gonna set your solution equals 0, okay? And then my solution was 5/7 sine of 14t equals 0, okay? Think about it. Sine function equals 0. The case is sine 0 or pi, right? Sine 0 is the initial, then like the first, or again, okay. The first time the motion come back to the initial position is what? What is it? In the graph, I'm talking about this point. Can you see like blue point? Okay. So that point will be when the 14t is equal to pi, right? So your 14t equal to pi, then your time t is equal to pi over 14 second. So which means that blue dot is pi over 14 second. Is that okay?